I see many discussions about whether a Z-rig or RADS system is a 2-to-1 or a 3-to-1, and I've discovered something that I think is not often mentioned that makes it easy to understand and easy for me to be able to tell whether something is a 2-to-1 or a 3-to-1. And when you ask the question if it's a 2-to-1 or a 3-to-1, it can be either. So that's, I think, what also adds to the confusion, because it depends. It depends on whose perspective you're talking about. Whether you're talking about a RADS Z-rig type of a system in relationship to the climber, or whether you're talking about a Z-rig in relationship to a grounds person. I'm using a picture in the Westberg catalog that helps demonstrate this quite well, I think. But in this photo you can see that the climber is either limb walking or going up a tree, but he has 3 segments to his climbing system. And the segment that is connected to his hand goes to a pulley. The evaluation is to look at that pulley and ask yourself if that pulley moves. If the pulley moves, then you can count the segment. So in this case, there'd be 1, 2, 3 segments. So it is a 3-to-1 system. Now, how do you know whether the pulley's moving? It doesn't actually have to move. It can be, in this case, it's connected to the anchor, and the pulley's not really going to move, but in relationship to the climber, it is moving. And that's what you have to ask yourself. Ask yourself, is the pulley moving closer to you? If the pulley is moving closer to you, then you can count it. If it's not moving closer to you, then you can't count it. In the case, if this climber was being pulled up the tree by a grounds person, and this was the hand of a grounds person, when he pulls on that segment, the pulley will never get any closer to him. It's stationary in the tree. So when he pulls on that, the climber will go up the tree, or whatever load he's hauling will go up the tree, but the pulley's not going to get any closer to that grounds person. And so he can't count that segment. So it becomes a 2-to-1. It makes it pretty easy for simple systems to determine whether it's a 3-to-1 or a 2-to-1. If this was a block and tackle and there were another 2 segments right there, again, it's pretty easy. It would be a 5-to-1 if you are using that to ascend the tree, and as you pull on that you get closer to the pulley. You would count the 4 segments from the block and tackle plus that other segment right there. Doesn't matter what configuration those are in, if you get closer to the pulley when you count it, then you can count that segment. If you don't get closer to the pulley when you pull on it, you can't count that segment. So it makes it pretty easy to determine. Here's another great example, again in the Westberg catalog, but they show a 3-to-1 Z-rig system. And you can tell it's a 3-to-1 because if you're standing here and you pull on this, that tree is going to come to you. The pulley is also going to come to you. It makes it a movable pulley. So you can count the segments. So there's 1, 2, 3, 3-to-1. Interesting. If you take that tree and move it here, and you take the anchor and move it over here, it is no longer a 3-to-1 Z-rig if you're still standing in the same position. Because now that being the anchor is not going to permit this pulley to move. So when you pull on this whole system from this position, the tree will come this way, but the pulley's not going to move. So you count the segments, 1, 2, 3 segments, but this pulley doesn't move, so that segment doesn't count. So it now becomes a 2-to-1. I have a representation of a RADS system or a Z-rig 3-to-1 system that we will try to demonstrate that it is 3-to-1, and there's 30 kilograms suspended on my floor jack right now, but this represents the attachment to the climber's saddle. This represents what the climber is holding with his hands. This is all from the perspective of the climber. Everything is in relation to the climber. This is from the climber's point of view. So I have an anchor that comes down for my first scale. It goes through the first pulley, goes back up. I measured the second leg with the scale, goes back through a pulley, comes down for the third leg, and I measured that with a scale. And then I have a scale to measure the force from the climber. What I expect to see is that these two scales are going to equal 30 kilograms. And I would expect these three scales to equal 30 kilograms minus whatever friction is in the system. So I lift the system, turn on, make sure all my scales are turned on and zeroed out, and I can adjust the tare weight a little bit and make sure that it's pretty close to zero. That takes into account the weight of some of the lines, carabiners and such. And those are all 0, 0, pretty close to 0. Now I let the weight down and let the system settle. And I'm looking at about 8.5 here, a little over 9 there, and sitting at about 12 here. And then I'm sitting at almost about 17.6, so almost 18 there. So the 18 and the 12, that makes sense. That adds up to 30 kilograms. And I've got 8.5, a little over 9.5, that's 18. And almost 12 here, fluctuating a little bit. Almost 12, so the 12 and the 18, those three add up to 30. What I'm kind of surprised at is that in the static, now everything's settled down, but the friction is still represented in those pulleys. And the fact that this one, the first one, is a little less than the second one is a little less than the third one. So the weight, as it goes through each pulley, doesn't make it all the way back to this first scale. That surprises me a little bit, but I'm pretty sure that is all due to the friction of the pulleys. And I can't manipulate this at all. Otherwise, I would be inducing an outside force into this system. So to me, this demonstrates that each one of these legs is a third, making it a 3-to-1. In this scenario, where the climber is hanging from a saddle on the system, not being affected by any outside forces. Here I have the RADS system, Z-rig set up, anchored to the tree. Comes down for the first segment, goes through pulley. Second segment comes down through a pulley. And in this case, I have it connected to a ground crew that's completely independent of the load, which is my 30 kilograms representing the climber. Take all of my scales and I will zero them out. Make sure I have slack in the system, and all of the scales are pretty close to zero. I lower the climber. The climber is suspended. I'm seeing 29.56, so almost my 30 kilograms there. Seeing 13.5 here, and I'm seeing almost 16 here, so that's almost 14 and 16, that's almost 30 kilograms there. And then what's interesting is here, with the friction, I'm only seeing 9.3. Now, if I was a ground crew and I wanted to lift that climber and I start pulling down, I can feel when the friction starts to release, and I can see that that's happening in about 15 or half. So I keep pulling down, and it goes as high as there's 19, and the climber's going up, there's 19, climber's going up, 18, 16. Now I'm holding the climber stationary, there's about 15, let the climber back down, there's 11, climber back up, it goes as high as 21, but it settles in at about half of the load, representing a 2-to-1 ratio that the ground crew is experiencing, unless he's just holding it. But while he's working it, while he's making the climber go up and down, it's coming into about 15, about half of that load while he's working it. I do find it surprising that on a static system, friction is still represented in the scale. So I took the 30 feet of line that I'd laid out and measured, and I put it up against the tree, and I have a tape measure on the tree to indicate there's 0, to indicate the perspective from the climber moving towards the pulley. And if this RADS is a 3-to-1, I would expect to pull 30 feet of rope in order to get 10 feet up the tree. I'm using just my hands just to avoid any confusion. But here I've reached the 10-foot mark, and I'm out of, there's the mark for the 30 feet of rope. So I have gone through the full 30 feet of rope. And there is my 10 feet of climb. So 30 feet of rope, 10 feet. I think that pretty well proves that it is a 3-to-1 if it's a climber ascending the rope or doing a limb walk. And there you can see all 30 feet of rope that has passed through my hands on the way up. Okay, now I've set it up to try to demonstrate a 2-to-1 mechanical advantage. The weights there represent the load of the climber or whoever you're going to pull up the tree. And I've measured out the rope again, and I'm going to start pulling on the rope until my load gets to the 10-foot anchor. And again, this is a perspective from the ground person using a Z-rig mechanical advantage. So I've pulled the load all the way up to the 10-foot mark, and there's the 20-foot mark on my line. We'll step back and take a look at the load. There's the 20 feet of line laying on the ground that went through my hands, and there's the load at the 10-foot mark where it was before. You can't pull any more line. The line's already pulled.